In this lesson, we will learn how to add and subtract polynomials. Recall that the set of integers is closed under the operations of addition, subtraction, and multiplication. Remember that what that means is if I add, subtract, or multiply any two numbers in the set of integers, the result will always be another integer. For example, 4 times 5 is 20, which is in the set of the integers. 3 times 6, which are two numbers that are in the set of integers, is 18, which is also in the set. So in other words, there's no way to get out of the set of integers by multiplying any two of them together, adding any two of them together, or subtracting any two of them. Now, suppose we'd like to simplify this expression here, 6x plus 11x. Well, since 6, 11, and x are real numbers, I can apply the distributive property in this way. So I write 6x plus 11x equals 6 plus 11 times x. The reason I can do that is typically you use a distributive property in this direction, starting with an expression like this, going here, by distributing the x inside to the 6 and to the 11 and getting 6x plus 11x. However, we can just as well go the other direction. So the reason why I do that is because you can see inside the parentheses, after factoring out this x, I have 6 plus 11, which is 17, and I'm left with 17 times x. So the distributive property justifies the reason behind 6x plus 11x equals 17x, or you could think of it as having 6 x's and adding 11 more x's, and altogether you have 17. Similarly, if I have 2x squared minus 9x squared, I can use a distributive property to factor out the x squared, but you have to remember the distributive property only applies to addition. Okay, so I need to change my original expression to addition. So I change this to 2x squared plus negative 9x squared, which is the same thing as this. And then I factor out my x squared, since the distributive property tells me I can do such a thing. And then notice that I have 2 plus negative 9, which is negative 7, so I have that 2x squared minus 9x squared is negative 7x squared. Once again, justified by the distributive property for real numbers. But I can just as easily say that I have 2x squared, and I'm taking away 9x squared to be left over with negative 7x squared. Okay, now if I wanted to add or subtract polynomials, I can combine like terms. That's basically what I do. Like if I have 6x plus 11x, that's 17x. However, you cannot combine, for example, 6x plus 9x squared. That does not equal 15x or x squared, because the powers on the variable have to be exactly the same. Okay, so let's say I wanted to add this polynomial here to this polynomial. I'm going to do so using a vertical arrangement. The first thing I want to do is put my polynomial into standard form. Remember, standard form is arranging the terms so that I have descending degrees of my terms in my polynomial. So I have x to the power 3 here, x to the power 2, x to the power 1, and x to the power 0 here written implicitly. Alright, so then underneath it I can write the second polynomial once again in standard form. However, I need to make sure that I align like terms. I put the x squared terms under the x squared terms, the x terms underneath the x terms, and the constant terms underneath the other constant term. Notice here that my second polynomial, it has no x cubed term, so I basically just leave that blank. And then I do normal arithmetics. I have 4x to the power 3 plus 0x to the power 3, so altogether I have 4x to the power 3. Here I have 12x squared, and I'm adding 5x squared to it. That gives me 17x squared. 8x, take away 6x, I have 2x, and 6 plus 9 is 15. So altogether, the sum of these two polynomials is this resulting polynomial here, using a vertical arrangement. I can just as easily use a horizontal arrangement as well. So let's say that I wanted to add these two polynomials together. What I would do is I would write the polynomials first in standard form. Notice that this first polynomial here is not written in standard form, since I have 2x minus 7x squared. Okay, so what I need to do is write the polynomial in standard form by making the powers of the variable so that they're in decreasing order. So I would have negative 7x squared plus 2x, as is shown here. And notice that this one is already in descending powers of x, so this one's already in standard form, so I just rewrite it here. The next thing I do is I group up my like terms. So notice I have a negative 7x squared term here and another x squared term here. What I do is, since I can combine these things, I group them in parentheses, and I do the same thing with the x term and the constant term. So in the end, I have negative 7x squared plus x squared altogether. That's negative 6x squared. 2x, take away 2x, that gives me 0x. And of course, I have nothing to add 5 to, so I bring that down. Excuse me. And then I have, notice that the 0x term here is the same thing as writing absolutely nothing at all, because 0 times anything is just 0. So in the end, I have that the sum of these two polynomials is this resulting polynomial here. Remember to come to class prepared with answers to these questions, your thoughts on these questions, because I would say that this is probably the most important part of these video lessons, is making sure that you reflect on these here. Alright, now to subtract polynomials, it's actually the exact same thing as adding polynomials, just like it's the same thing when you're subtracting two numbers. Like, for example, let's say you're subtracting 5 minus 3. That's the exact same thing as adding the opposite of positive 3, which is negative 3. So I could easily write 5 minus 3 as 5 plus negative 3. Well, when I'm subtracting polynomials, since polynomials are essentially numbers, once you plug in a number for the variable or substitute a number in for the variable, I can treat them like numbers. So let's say I'm subtracting polynomial a minus polynomial b. What I would do is I would take a and add to it the opposite of polynomial b. So I would have a plus the opposite of polynomial b. You'll see in the following example, it shows us how to use this method with the vertical and the horizontal formats. So here we go. So notice here, I'm going to be subtracting this polynomial from this polynomial here. Okay, so we're going to use a vertical arrangement. The first thing I do is write my first polynomial in standard form, 9x squared plus 2. Now remember, I'm adding the opposite of the second polynomial. So I take the opposite of each of these terms. So notice the opposite of negative 6x squared is positive 6x squared. The opposite of negative 3x is positive 3x. And the opposite of positive 1 is negative 1. Adding these guys up, combining my like terms. Make sure you line up your like terms here. Okay, so I have 9x squared plus 6x squared is 15x squared. Notice that my first polynomial has no x term in it. So I have 0x, so 0x plus 3x, that's 3x. And I have positive 2 minus 1 is positive 1. So the difference of these two polynomials is this polynomial here. Alright, so let's say I'm subtracting these polynomials once again. I can treat these two polynomials as if they're numbers because they are numbers once I plug in a number for x. They turn out to be some number depending on what you substitute in for the value of x. So let's say I want to subtract this second polynomial here from this one. It's the same thing as adding the opposite of the second polynomial. So we're going to use a horizontal arrangement this time. So I rewrite this problem. The next thing I do is I rewrite it so that it's an addition problem. So I take my first polynomial, and this time, since I'm subtracting, I'm actually adding the opposite. So I'm adding the opposite of this entire polynomial. In order to find the opposite of the polynomial, I take the opposite of each individual term. So I'm adding the opposite of 4x cubed, which is negative 4x cubed. The opposite of 6x squared is negative 6x squared. The opposite of negative 2x is positive 2x. And the opposite of positive 7 is negative 7. So once again, like I did before, I combine up my like terms. So notice I have 6x cubed, so my x cubed term combines up with this x cubed term from the other polynomial. So I get 6x cubed minus 4x cubed, which is this, and then I have my x squared term from this polynomial combined with the x squared term from this polynomial, and so on and so forth down the line. Simplifying these, I get this polynomial here as a result of subtracting these two. Okay, so in this problem, what we're going to do is the U.S. Census Bureau maintains data on the enrollment in the high schools. So what they found is that this polynomial here will model the high school population of males in millions of students across the entire United States. X number of years since 2000. Alright, so M of 0 would represent the number of male students in millions 0 years after 2000, or in the year 2000. So the high school population is modeled by this polynomial here of third degree. Same thing with females. Okay, the females, the population of females is modeled by this polynomial here of degree 3, where once again x is the number of years since the year 2000, and f of x is the number of female students in millions some years after 2000, x number of years after 2000. And our job here is to estimate the total number of students enrolled in high school in the U.S. in 2007. So I'm looking for the number of males plus a number of females. So we need to come up with a plan, and our plan is to find the total amount of students, some amount of years after 2000, x number of years after 2000, and of course it makes sense to add the two polynomials together, because after all, this gives us the total male population x years after 2000. This gives us the female population x years after 2000. Adding those two together will give me the total number of students enrolled x years after 2000. Okay, and then after I found out what t of x is, I need to evaluate t of x at an appropriate value of x in order to find out how many students total I have in the year 2007. So the first thing I'm going to do is I'm going to add the polynomials up. Once again, as shown in examples 1 and 2, you need to line up the like terms and perform the addition to get your resulting polynomial. So this right here is our polynomial t of x. So the next thing I want to do is I want to evaluate t of x at an appropriate value for x. Well, I'm looking for 2007, the population in 2007. So then that would be 7 years after the year 2000, so x would have to be 7. So I substitute in 7 in my function for the total population, and I get 17.1. But you have to recall that this gives you the population millions of students. So there will be approximately 17,100,000 high school students in the year 2007. Alright, so in this lesson we learned how we can add and subtract polynomials. You can add the polynomials either by writing them vertically and aligning like terms and adding their coefficients, or you can add the polynomials by writing them horizontally and group up the like terms and then add their coefficients. Subtracting polynomials is the exact same thing. With subtraction, like for example, let's say you're subtracting polynomial x from polynomial y, then so in other words, you're doing y minus x. So in order to subtract those two polynomials, you're actually adding the opposite of x. So you would have polynomial y plus the opposite of x. And of course you can perform this addition in the horizontal arrangement or vertical arrangement as shown in the few examples before. Alright, so to summarize, make a table describing the methods for adding and subtracting polynomials horizontally and vertically, and for each method provide an example, and do not forget to answer the reflect questions.